So in 10.5, this was all the angle stuff, and then 10.6, we got into all the lengths of stuff. There's obviously the prior knowledge, like you need to know what a central angle is, you need to know what an inscribed angle is, all that stuff comes from before this, but in 10.5, we learned about a couple of different, the angle relationships. So if I had two chords, and this is like your floating angle one, if I had two chords, and they form an angle, let's say I want to find angle 1, then I would add the two arcs and divide by 2. So I would add AB plus the arc its vertical angle intercepts, and then divide by 2. Again, this is kind of like we referred to it as the floating angle, but is an angle formed by two chords.
What about trying to find,
Then came a chord and a tangent. Actually, I think the order was reversed on that, but in this section you had both of these. So if I have a tangent and I have a chord, the angle formed by it is also the length of half that arc. So similar to an inscribed angle. Angle 1 would equal 1/2 AB. So the angle formed by a chord and a tangent is equal to 1/2 the arc it intercepts. And if I went the other way, if I wanted to find angle 2, then angle 2 would be 1/2 arc ACB, so the whole other arc. Together they would add up to 180 because they form a line.
Can you just warm the room?
I would love to. If that was like something I could do, I would certainly have done it for you. It's like the Arctic in here. Yep. Questions on that one? Okay, then came two secants, tangent and a secant, and two tangents, and these are all the same. It is big arc minus little arc divided by 2 equals the outside angle. Or the exterior angle, same thing. So it would look like if it was two secants, if it was a tangent and a secant, God bless you, and if it was two tangents, which looks like the ice cream cone, but we're using it for the angle and not the side lengths. So if this is angle 1, angle 1 here would equal arc AB minus arc CD divided by 2. Angle 1 here would equal arc AB, actually there would have to be another letter, ADB minus arc CB divided by 2. And that last one, angle 1, would equal arc ACB minus arc AB divided by 2. So again, big arc minus little arc divided by 2 would equal the outside angle or the exterior angle.
Can you move to the left a little?
I would say if you don't know these by now that I would start to write them over and over again until they sunk in. So like maybe in addition to tonight's homework, you spend the time trying to do this. And again, we'll do it one more time tomorrow, okay? But if you are not a photographic person, if you are somebody that you know you learn from writing it, then you need to make sure you're writing it out. Those are the angle ones. Those were all from 10.5. Then in 10.6 came all the segment stuff. So two chords. Now we're not talking about the angle anymore. We're talking about the lengths of those segments. And it would be A times B equals C times D. We would multiply the segments of the same chord together. Then you had 2 secants. And this is whole times external equals whole times external. So if I had the whole of the top, it'd be A plus B, whatever that length is, times the exterior part, which is B, would equal the whole of the bottom secant, which is X plus Y, times the external part there, which is Y. And then you had a tangent and a secant. And this is whole times external equals tangent squared. So A plus B times B, the external part, would equal X squared. You're going to see at least one in which you're going to have to factor. So if those are the skills you need to spend some time on, then go back and practice some more factoring. And again, we're going to add to this today. Today's a little bit different because it's circles in a coordinate plane, but so it continues with circles, but a little bit different. Last section in chapter 10, which is section 7, and it is called circles in a coordinate plane. So we're moving back to a coordinate plane in XY axis, okay? You're going to learn how to find the equation of a circle. You're going to learn how to find or graph a circle from an equation. So the first thing is if the circle's at the origin. If you have a center at 0, 0, that's where your origin is. That's there in the middle. R is the radius, and the radius is the length from, or the distance from the center to the side of the circle. The equation is x squared plus y squared equals r squared. Okay, where it stays as x squared, it stays as y squared, but you will replace the r with the radius, and then you'll square it. This is, again, only if it's at the origin. In a minute, we're going to learn what happens if I move it. And it basically just comes from your Pythagorean theorem. Like you see there's a little right triangle drawn in there. That's how that equation was derived. Okay, the distance from the center to the side, which is the radius, would be the C part of your triangle if you'd use the Pythagorean theorem. That's where it comes from. So this one says, write the equation of the circle shown. And again, the importance is to note that the center is at the origin. So this is going to change, but for right now, the center's at the origin. So I know my equation is x squared plus y squared equals r squared. Now I got to figure out r, and I can count in either direction, to the right, up, left, or down.
So basically we're just doing Pythagorean theorem?
No, you don't actually have to do the Pythagorean theorem. That's how it's derived, but you're not actually doing it. Because what's the r?
I don't know.
What's the distance from the center to the side of the circle?
5.
5. That's your radius. So this becomes x squared plus y squared equals 25. That's it. I mean, when the center's at 0, 0. Yeah.
So now is that the answer?
That is the answer to this question. Yes. All right, now it says, write the equation of a circle with a given center and radius. You no longer have a picture here. But notice that every single one of these has a center at 0, 0. So for all of them, we're using that same equation. X squared plus y squared equals r squared. So for A, I'd get x squared plus y squared equals what? 16, r squared. For B, I get x squared plus y squared equals what? 5. 5 is the square of the square root of 5. And then C, x squared plus y squared equals 4 root 3 squared, which becomes 16 times 3, or 48.
Wait.
When you square, you square the 4.
3 equals 48.
Right, you square the 4 and you square the square root of 3. Or you could multiply 4 square root 3 times 4 square root 3. It's the same thing. This would give you 16. This would give you 3. Questions so far? All right, now what happens if I shift my center off of 0, 0? The center is now HK, H being the X coordinate of my center, K being the Y coordinate of my center. If I wanted to find the distance around the circle, I would use the distance formula with those coordinate points, which is what this is. You don't need to do that, however. You can go straight to the standard equation. So the only difference is you now have an H and a K. H is the X coordinate of your center. K is the Y coordinate of your center. Notice it's a minus, so you always change the sign.
Always subtract.
Correct. All right, so now it says write the standard equation of the circle with the given center and radius. So now my center is no longer at 0, 0. My equation is x minus h squared plus y minus k squared equals r squared. So for A, this is my h and this is my k. So x minus 1 squared plus y minus 2 squared equals 4 squared. And x minus 1 squared plus y minus 2 squared equals 16. That's the standard form of your equation. Yep.
Wait, so solve it up.
Nope, you're just writing the equation.
So
You can't solve it, there's two variables.
So basically the 1 and 2 serve no purpose.
No, the 1 went here and the 2 went here.
We have to solve for them next.
Not now. No, but you'll see where you get a point and you have to find the r. We're going to do that
So you
too.
do have to solve for it.
No.
Not now.
It'll never say solve the equation of the circle because there's two variables. You can't do it.
Okay. So we're going to have to solve for x or y.
It is impossible to solve for x and y in this equation because
You
there's
have to
two
solve for
variables.
Every single variable there.
All right, go to B.
Yeah.
So here's my h and my k. This time there's a negative there, so if I did minus negative 3, what happens?
Plus
It becomes x plus 3 squared plus y minus 5 squared equals, and the square of the square root of 5 is?
5. Right?
Yep, good job. Questions on that one? All right, C again, here's my h, here's my k. So it'd be x minus 0 squared plus y plus 2 squared equals, we already did this is 16 times 3, which is 48.
48.
Now you do not need the minus 0, so this simplifies to x squared plus y plus 2 squared equals 48.
You have to do that, though, or?
Well, the questions on the homework on this one, I'm pretty sure, if I remember correctly, are like matching, so you won't see it. If you were to give me that on a test, like as an answer, I probably wouldn't take the points.
I have a question.
All right, now we're doing it from a graph, but still the same goal here, right? The equation of the circle. So from A, I need to find, well, from both of these, I need my center and I need the radius. What's the center?
4.
4, 1, so that's my h and my k. How do I find the radius?
And then the radius would probably be 6. Then what?
We literally count it, right? From the center to a side would be 1 here. Pay attention because this unit is 1. If that changes, obviously you need to pay attention to it. If it said the unit was 2, then that r would be 2. So I'd get x minus 4 squared plus y minus 1 squared equals 1 squared, which is 1. Good morning. Thank you. Questions on that one? Okay, go to B. My center is negative 5, 3. My radius is what? 3, good. So x plus 5 squared plus y minus 3 squared equals 3 squared, which is 9. Questions on either of those? Honestly, this lesson should be so easy. Like the things people make mistakes on are forgetting to square the radius and then messing with the signs. So just be careful on that stuff.
Pretty easy.
It should be. All right, now we're reversing it. Now we've got the equation and we want to graph it. So I need to pull from each equation its center and the radius. So if I look at A, what's the center? Good. 3, -1. You change those signs. And what's the radius? 2, because we square root the 4. So I plot my center, 3, -1, plot a point. And then I count up, down, right, and left the radius. So from there, I'm going to go up 2. I'm going to go left 2, down 2. Right 2. Sorry, I went the wrong direction. And then just connect it as best you can. It doesn't have to be perfect.
Ooh. How come it's not on -3, 1?
It's on 3, -1. Remember, you have to change the signs. So whether you're putting it into the equation or taking it out, the signs will change. What's the center of B? -2, 0. What's the radius? 2. So my center's at -2, 0, and my radius is 2. To the right, up, left, down, 2. If if the r squared is not a perfect square, you might be approximating that. If that said 5, let's say, then my r would be the square root of 5. I'd be approximating that to be like 2.1. That would be the only other variation you could see on that stuff. If it's not a perfect square, you're just approximating it to graph it. Questions on those? All right, and then this last one is where it gets a little bit trickier because it's saying to find the equation of the circle. It gives you the center like we're used to, but instead of giving me the radius, it's giving me a point on the circle. So if you wanted to get a visual on this, and it doesn't have to be perfect, but to just get an idea, -1, 3 is my center. -5, 6 is my point on the circle. So it's doing something like that. If the point on the circle was horizontal or vertical from my center, I could literally just count those points to find the radius. But most likely in a question like this, it's not going to be that case. I have to figure out what the radius is by using the equation and plugging in the information I have. So if I have x minus h squared plus y minus k squared equals r squared, and my center is my h and my k, and a point on the circle would be my x and my y. Now I have everything but the r. So I'm going to plug it all in. -5 minus a -1 becomes +1 squared, plus 6 minus 3 squared equals r squared. Biggest mistake people make here is forgetting to square them. So now -5 plus 1 would be -4 squared. 6 minus 3 would be 3 squared. And I'd get 16 plus 9. 25 equals r squared. And r would equal 5. Honestly, I don't even have to do that last step because in my equation, I keep it as r squared. So once you get to r squared equals 25, you can jump straight to the equation. X minus a -1 would be +1 squared, plus y minus 3 squared equals my r squared, which is 25. Be careful here and make sure you use the center for these points because that's another common mistake, people pulling from the x, y. It's got to be the center.
Wait, so the -5 and the 6?
Are your x and your y in that equation. So you use them the first time to get the r squared, but then you're done.
And how is r going to help us find the other radius, or the other points?
Well, you're not using it to find the other points. You're using it to find the equation.
Oh, so we're not gonna have to do that?
No, we just found the equation. That's what we just did. We found the equation. You're going to do this exact same thing. Yes. Yeah. Yep. Yep. You can, but that's not, it's not asking you to find R, it's asking you to find the equation. So the equation is your answer. So if it said find R and then the equation, then you need both parts. But if it's just asking for the equation, which this one is, then you can stop at the R squared. Let's do another one. Add center to -3, point on the circle. -1, 5. Do this one. Everybody do it. So this is, again, be careful which ones you make the X's and the Y's. I mean, X, Y, and the HK, because it will give you the wrong thing. The center is your HK. The point is your XY. So if I did X, which is -1, minus H squared, plus Y, which is 5, minus K, minus a -3 becomes +3, squared equals R squared. I get -3 squared plus 8 squared, 9 plus 64, and R squared is 73. So I can stop there because it didn't ask me for R, it's asking me for the equation, and in the equation I keep it squared. So then I'd get X minus the H, which is 2, squared, plus Y minus a -3 becomes +3, squared, equals the R squared, which is 73. Raise your hand if you got it right. Good morning. Questions? Yeah.
Here we left it in the equation, but we got it.
I said you didn't need to do that. If it asked you for the R, then it would be like R. I would go to the next step. R would equal the square root of 73. But because it doesn't, the goal here is just to get the equation. You don't have to do that step because you can just leave it squared. Yep. And if I was to graph this, I'd approximate that 73, that it's 73 is in between 64, right, which would be 8 squared, and 81, which is 9 squared. So it would be in between there. You can approximate it, like an 8.5. It doesn't have to be perfect, but if I was to graph this, I would approximate it. Yep. What do you mean, have to put? No, the equation has to have the H and the K. So the equation, the only variables in an answer for an equation to be the X and the Y. Questions? All right, so the big ideas is open. You've got like 30 minutes. My advice would be to do that now. You have to be productive in one way, shape, or form. Either you're working on that now, and then you can do the review this evening, or vice versa, okay? But the review is also open because this is where the new content stops. And we'll review tomorrow and then test Thursday.